So welcome everyone. Today, now we start the first tutorial, and now we learn how to configure Andromeda search engine. Throughout the tutorial, you can ask any question to me or any of the MaxCon team. We are all running around, so you are free to ask any question. So I will show some of the slides, and then I will also at the same time open the software and then go through it together, each assignment. And before we start, please copy all of the contents from USB sticks to your software, to your computer. But for this tutorial, you actually need only this software, which is MaxCon. It will take some time. That's why we advise you to actually start copying now. I know that yesterday Pavel already tell you to do it, but if you didn't do it, just in case. You heard yesterday and today from Petra, and today Petra together with Fabio about the details related to the Andromeda search engine. And you remember that we still record, and then this recording will be available on our YouTube channel, so you could always go through there and then check the videos. But if you also want to read the original paper of the Jürgens, which is published in 2011, you could go there and then read the details. We could say that Andromeda configuration has at the moment currently two specifications. The first one is about modification or label, and the second one is about Proteus. In most of the cases, for most common Proteus, most of the modification is already configured. You don't need to worry about it. I don't know how many of, I think like Jürgen was mentioning on the first day, there are like some number of experienced users already here, but I think 50% was new user, right? How many of you are new? Never worked with MaxCon before? Okay, so you may be surprised, the experienced one, we don't actually put sequence database anymore because you don't need to configure this. So therefore, we skip this part. But for the fresh people, you shouldn't worry about what I have said. You remember what I was talking about yesterday about cross-linking, and then soon there will be one more specification that you could easily configure your cross-linker. So throughout this tutorial, we will configure our search engine. So we will add a new modification. Imagine that we have actually like more than 500 modifications listed over there, but you may still need more. So we will do this. And then we will also add some hypothetical site label. And you will also learn how to add a new Proteus. And in the new format of MaxCon, now you will also see where you could add the FASTA file. Most of you, I noticed that you were here for Pavel's talk. Pavel already showed you where it was, so we can quickly go through it and then again remember where we could add the protein database. And the last one, just quickly showing where we could actually, in the future, you will find the Crosslinker. So let's start with the new modification. Before we start, there is a good resource out there called Unimod, and it contains a list of possible modification. So this is when you log in. This is the start view. And as you see, there's a short overview, and then we have the accession numbers. And then we also have the PSI MS name, Protein Standard Initiative Mass Spectrometry Working Group defined name for this modification. And some short names is intermin names, and the description related to the further detail about modification. And some of the mass changes. Mass is important for mass spectrometry, and the composition. And our first task is to add the Hydra Learning from tyrosine. And then we will find it on Unimod. And this is like the screenshot that from Unimod related to this modification. And what we need to know to configure MaxCon, the composition. And then the specificity detail, which amino acid is targeting, and what kind of the modification is this. So in order to this, we go to the MaxCon software, and then we open the configuration tab, and here we go to the modification page. So let's start it. So first I go to the Unimod, So it's already somehow login. So this is actually the start page. So you have two options to log in. You either log in as a guest or register. So I prefer guest. And I'm clicking on it now. And now we have the list. So here you could search easily for any field containing our keywords. And we will put which modification we want to search for. And then we start the search. And now we have three options, but we know that the PTM that we were looking, it was from tyrosine. So we could go to the first one, get the view, more details. And here was exactly what you have seen on the slide. So what's the accession numbers, and PSI MS name, and the description, the long description about this modification, and the composition. And this specificity detail is happening on tyrosine everywhere. Since we know which modification we want to add, let's open MaxQuant now. Most of you, I hope, already copy and have the software. Sorry?
My MaxQuant headers are in German.
In German. So it's the system default, it must be. So you should change your system settings. I think your Windows is in German, maybe? No? Huh? Must be, yeah? So everything is German? You say file, I mean...
No, so only the main tabs are in German. The rest is
Okay.
should be okay.
Okay.
Learn a bit of German.
I mean, it shouldn't be, but we don't know why. But every one of you has the right software now? You don't have any issues to open?
Maybe I can just reply to that. So it's not necessarily the operating system that is in German, but you have something like regional settings, right? And this is in German, even if it's an English Windows. So if you see German words in the MaxQuant GUI, it has to be the case that your regional settings are German for whatever reason. Yeah, I mean, it should be whatever you want. If you want to see English there, then it has to be English. So.
Or you could also see Spanish, right? Yes.
Turkish.
And Turkish too, yes. It's good. Okay. So when we open the MaxQuant, maybe it's a bit too much information at one step, but by the end of these tutorials, this one and the upcoming ones, you will have enough experience to know and then configure your search for and do confidently doing MaxQuant results. So therefore, I will just skip the first part, and then our task now to do configuration. So we go to the configuration tab. And then here we have the modification list. So we could sometimes, because in order to get the best out of it, you could already check what was written. So let's check the oxidation. What we know in general about oxidation is happening on methionine. So we have a name. The name will be important when we set the settings later. But description is more like to you important and later for you to important. And here, name, description, and the composition. What is this, the formula about this modification? And here we have the mass, monoisotopic mass value, and the position-wise. Is modifications happening everywhere, or only C term, or N term, or specifically protein C terminus? We say this standard. It's standard because it's post-translational modification, but we have also other type of modification. And we will come to the label one on the next assignment. And then it could be also possible to add a new terminus. So when you have a new modification, the modification will also result maybe having a new terminus. So here you can define But what we know, oxidation of methionine doesn't result any new terminus. And this specificity detail here. Which amino acid is targeting? It's methionine. So there are two ways to add modification. Either you can duplicate or add. So let's try the first option now, the second one that I say, adding. When we add, there are some default explanation saying like new modification. And then we could go to the unimod. Let's use this intermean name for this name. And a description. Description is as written here in unimod. We could copy-paste this part. So far, so good? Or do you have some question? And then here, the composition, we need to change it. We need to define the formula for this modification. We could delete this with backspace, and then we go to the change. And in this change, you could see the elemental table, periodic table, here. But I will use the drop-down menu. So what we know on unimod, the composition, it was like -6 hydrogen. So we go, and then we lower the number, 6 times hydrogen. And we check what was the second part. It was the carbon -6. We add carbon -6. And oxygen -1. And when we write this composition, we see the formula here, and we could also see the mass information. This is monoisotopic mass. It was -94.0418. And let's check unimod. If we get the same, it's the same value. And then we click OK. And the next step, the position. Position here was mentioning anywhere, and we also have anywhere selected. Type is standard because of modification. There is no new terminus, so it's none. And the specificity-wise, it was tyrosine. So we go, and the specificity detail here, we could remove already by default amino acid by minus, and add the new one. So we nicely set up now the modification from unimod. We don't need to add any more for this modification. So what we have to do and must do, what always needs to do, modify the table. You may see that we already changed this part, but there's no changes happen on the table. The only way to make the changes here, to modify the table. But that's not enough. You can still discard the changes or save the changes, so you need to save your changes. Do you have any question so far? Then we go to the next assignment. So the next assignment is adding a new Silac label. Again, we go to the modification. You remember on the modification on the types, we have standard, label, and so on. And then we use the label ones. And then we add this histidine 8. This time I will use a duplicate, but here it's good to know one more function. It's Control F. When you're on the modification tab, if you put Control F, you could search some of already existing modification. So I do Control F, and I know that there's lysine 8, which is also a sci-like label already configured in MaxQuant. Okay, so we do Control F, and then we have this find menu, and then we know that lysine 8 is already exists, so we say lys 8, and find next. So here, I will use the duplicate function. Go here to duplicate. It's a copy of the lysine 8, and the rest is the same. So we will modify this part. So the name, it will be histidine 8. And the description is, as I say, is useful for us. So we say, again, histidine. And the formula was 13C5. I close this part. And 15 nitrogen, 3. Sorry, slide? Yes. Yes? So,
at this stage, if I close the MaxQuant program and reopen it again, it would have this new table that I have already
yes.
saved. Okay.
Yes, and then you could also find the modification XML in one of the config folder on MaxQuant. It should be there. Yes, it will be there. And then we remove the composition. And again, we go to the change. It's 5 times of heavy carbon. Heavy carbon is CX. And we go up to edit. And then we need to subtract the light ones. So to subtract, we go down. For the nitrogen, we have 3 times heavy ones. Nitrogen. Okay. I hope all of you did the same and get the same value. Like we was expecting histidine 8 Dalton differences, and we see it here. So, okay. We know it's anywhere, it's a label modification, but it's not on lysine, it was on the histidine amino acid. So we remove it, and we add histidine. And again, we need to modify the table and save our changes. Do you have a question? Otherwise, we go to the next tutorial, next assignment now. Before we start the next assignment about this modification, it will be good for you to make small advertisement about one of the lecture. related to dependent peptide. Sometimes you know what you're searching for your sample, but there might be some interesting modification, and then you can find them with the dependent peptide option. And then Friday in the morning, Pavel is going to give you details about this dependent peptide option. Now we add a new protein data, new Proteus. And then you need to go to the we will again say in the same configuration tab, we go to the modification Proteuses, and then here we will go through together now. So we come to the Proteus, and let's check out one of the commonly used trypsin enzyme. So name, as I say, all the names configured here will be later important as when we set our settings. And what we know in the description, trypsin cleaves after lysine and arginine, but not before proline. Here is all the amino acids are enlisted, and then here is the alanine plus and this alanine minus, and here is the same. And what we know, this arginine is the single letter is R, and then here is, and then when we click on this plus, it selects all the rows. And the second part here, for instance, R and A, arginine and then alanine, showing that you have this two position on your peptide. So it's cut it. But what we say, not before proline. So then you go to the here, proline minus, and then you deselect. Because when R and P next to each other, the trypsin is not going to cut over there. It's the same for lysine. Here you could add a new Proteus. I will do something hypothetical, but yeah. So it's super trypsin maybe. So I select all the arginines and all the prolines and also all the lysine. So I even break all the rules. So I mean, it's up to you. It's just for the demonstration purposes. Has nothing. But yeah, you could add any of your Proteuses. But if you have anything in your mind, let's add that's more specific, scientifically true Proteus now. But what you need to do is now modify the table and save the changes. And in my case, I know that this lysine doesn't exist, so I can go here, and I can actually clean up my mess, and I could remove what I already added, actually, which was not right. And then save again the changes. Do you have any question so far? Yes?
Is there any database where you can find the specificity for any new protease enzymes?
As far as I know, I don't know any. Maybe Protein Standard Initiative, maybe they have a list over there, but I didn't check in, I'm not sure.
Can you repeat the questions when he doesn't have a microphone?
So if you know in advance any database that have list of enzymes, I don't know, but maybe the human PSI group has it. Protein Standard Initiative for the mass spectrometry group, maybe they have. Any more questions? No.
Can I ask a general question, actually? The default is trypsin P.
Yes.
We have searched a number of data files, and actually we don't see many cleavages KP, RP. I was just wondering why it was chosen this as default settings. I guess it's trypsin dependent, but in our experience, the default would be trypsin, not trypsin P.
Well, I think most of the searches by society we use trypsin P, but Jürgen, do you want to comment? Microphone?
Yeah, I think as you say, you don't find many, but you do find some, right? And these you would lose if you use the other trypsin definition. I mean, it doesn't hurt to use it, basically, right?
But trypsin, normal trypsin that you buy from, I don't know, Promeva or something, normally doesn't cleave after proline.
Yeah, you all use words like normally, usually, not so much, but to some extent it does, right? And you still want to see those where it does cleave.
I mean, for example, in the case
You have never seen a case where it cleaves?
BC plus trypsin, it's okay to use trypsin B, no?
So, I mean, you're free to choose any of the two, right? But we definitely have seen examples where it actually does cleave. So.
But of course, you could change during the setting configuration to trypsin if you don't want to use the default settings. That's why we are all here, configure your search engines. And do you have a question? No, I also know there are some studies are showing that trypsin P was better than trypsin, so it's good to choose this as a default.
After P. So normally, trypsin P doesn't cut. It's the other in the other way.
Yes.
And here you have trypsin P cut before P. And in mascot, trypsin P doesn't cut. Does cut.
But this might be maybe minor search engine on the trypsin. It doesn't cut on P, but we exclude. No, we remove this rule. That's why.
So I mean, it's of course nomenclature, right? So
Yes.
so how we call it is the one with P does cut, right? And what is just called trypsin does not cut. So that's how we call it. What? Okay.
But in mascot it's underscore, no? The default is not like slash, because here we have a slash.
Yeah, okay, then maybe we can agree that the nomenclature in mascot and maxcon is different. But then, is there a right or wrong in the nomenclature? I don't think so. So that it's just how it's called, basically.
But if you are not happy, you can free to configure Andromeda, so you can change this for your settings.
So one more unrelated issue that I saw, a few people have issues with saving the table, access denied, and I think this happens because some of you might have the MaxQuant installation in a place where they are not allowed to overwrite files or create new files. So for example, if you're not the system administrator, you're maybe not allowed to write in some places. So just grab your entire MaxQuant folder and move it somewhere personal, for example, the desktop, just for now, and then you should close MaxQuant, open it again, and then you should be fine to save the configuration.
Yeah, just one last question. For the future,
Sorry.
yeah. It would be nice if one could just, import the Unimod modifications instantly from
Instantly.
from
but
the
there are only
database.
like 500 modification is so.
Instead of like copy pasting information, that's just a suggestion to future improvement.
Okay, okay, I understand.
Hi, just one more question. What is the authenticity for adding new modification from the Unimode? Is it all authenticated enough that I can just simply trust? Or, for example, one has to be cautious in adding a new...
My advice, first try to search if your modification already exists on the table, like Control F and then the Hydra Learning. If it doesn't, or if you don't find anything, you could go and then add the modification. The description will be therefore important for you to find what kind of modification already existed.
Okay, thanks.
Şule?
Hi, one more question before we go back to schedule. Here we're dealing with looking at trypsin and like adding that as the protease. What if we're dealing with a protease that has very broad specificity, like cleaving at C-terminal of all aliphatic and aromatic residues? Would you suggest using this this configuration or doing like a semi-tryptic digestion search?
So you have a new Proteus, and it's cut on the C-term. It's not.
It cuts at
any amino acids.
Aliphatic and aromatic residues.
So you know which kind of residues are they?
We know, like.
So you can choose on the table which residues you want to add and select it.
Okay, so you would suggest doing that rather than doing a semi-tryptic search.
You could also do it's semi-tryptic is different. Tryptic, semi-tryptic, there. Yes, maybe on specific you can do it, but there is these options later. MQSS is tryptic, semi-specific, free protein N-terminus or N-terminus, so you could try some option from there, or unspecific or no digestion at all.
Okay, thank you. I'll ask.
I have a short question or suggestion. What about adding a number from Unimod, like identifying number for searching in the table of modifications? It would make it sometimes easier to search if you go for searching into Unimod and then search then again in the MQSS.
This could have been an option, but yeah, we will check. We will note this one for maybe further improvement then. Okay, so now we add the protein database. And then there are two important public sources for database. One is Ensemble, and the other one is Uniprot. So if you have any question, we have an attendant, Emmanuel Alpi, and then he can help you with any question. So the main differences between these two, Ensemble is more gene-oriented. So you may have some more protein pseudogenes over there, but for Uniprot is more, they are well synchronized. And what MQSS does when you give this FASTA file, it adds automatically the decoy databases. So you remember from Andromeda peptide search engine tutorials, we were talking about the target decoy. Here you shouldn't worry. You should just give the FASTA file containing your target proteins. And you could add your common contaminants. As a matter of fact, it's by default. And then we will see where you could see and deselect this. And it's also important for you where the contamination FASTA file is located. Let's imagine that maybe you are working with bovine serum albumin, and it's already commonly listed for the contaminants. So I advise you to delete that part, because you know that your sample actually has this, but it was already listed for common contaminants. And then here, what was basically showing, so we go to now the sequence step, and add one of the FASTA file. And when we were adding, it's important also know the regular expression. But you shouldn't worry, because most of the public sources like Ensemble, Unimod, Uniprot, and so on, these are already configured. And then you could also find information on the JPR paper of Jürgen Koch for this Andromeda. And then here I actually quickly show it. For Ensemble, up to the first space is identifier. Identifier is important, it's like unique feature about this protein name. And it's for Uniprot, it's a bit more complicated, but it's already default, so as I say, you shouldn't worry. And in this part, here, we included the contaminants. And you could also deselect to remove the contaminant, but our advice, always search with contaminants included. So we can, again, go to the ensemble, go to one of the public resources, let's Google Ensemble. And then from here, we go to the download. And the databases. Like for human, there's a different kind of format because, as I say, Ensemble is more gene-oriented, so you could find all this DNA information or cDNA. But what we are interested in actually the protein databases. So in the earlier configuration tutorials, we always search for kangaroo, rat. So we could download this file again and to see what will happen. So we go to the FASTA. And this include all the gene-oriented products, this ab initio. And we go to the second one and download the files. And here, as you see, this is a species name for this kangaroo rat. So we could also do the same for the UniProt. If you are all okay with this ensemble steps, I go to the UniProt step now. So we go to the UniProt. So I copy-paste this species name. And then there's like review and unreview. The review ones are manually annotated ones, and the other ones automatically edit. And then we could say download all. So it's zip, so we remove the zip. Okay. There's no, right? Huh? Okay, I already get this FASTA files before. It was on my desktop, presentation. Tuesday, tutorials. And here we have the database. This is from UniProt, and this is from Ensemble. So we could, these are the FASTA file. This one is the extension is also FASTA, as you see. And then we could open this with a notepad or something else. Okay, so I am a bit slow now, so I wait for you to finish the download. 20 minutes, okay, so another thing is there is also another FASTA file on your USB sticks. We could also use this one. Here on USB, data and FASTA. So we could open this one and see how this is UniProt style. And then we can see this is the header information, this is the protein sequences. And now we add this to MaxQuant. All of you found the FASTA file on USB sticks? Buldular mı? Bitecek ya. And we got here the global parameters. On this, it's by default, the opening was this sequence tab, and then here we add this FASTA file. So all nicely set up because MaxQuant by default know how to handle UniProt. And then we could check actually how here there's this test. We select the FASTA file and go to the text button next to the variation rule. Did you find it? Because I read it smallly, so you can. Okay, so I just open. Do you have the FASTA file now? Okay, so after the FASTA file, you just still. No, we could quickly say it. So probably some of them also. You are on MaxQuant, and then you go to the global parameter, and then we just add the ads over there. Yes.
Hi, one question. So in the folder of FASTA that we got in the USB with the same number of FASTA, there are one and another one that says additional.
So this will come for the next tutorial.
Sorry.
It was just.
So we use the normal one, not the additional.
Yes, but you could. My idea is to show you how you could actually upload the FASTA file. Doesn't matter which one you choose.
Hi, I have one question regarding the organism. If you are working, for example, let's say with green plants, because your species of interest is poor sequenced or something, is there any way to indicate for example, in the protein group, the different organisms of these proteins?
The taxonomy ID will, and then later you will have the table information, and then you could work on parsers to get more the result. I mean, that's why the taxonomy ID is important when you have more species on your search.
Okay,
you could define it here.
Okay, thanks.
A question about the same taxonomy rule field. Does that need to be filled? And I'm asking that for those that do ancient proteins, we're working on organisms that do not have taxonomy IDs allocated to them.
So you want to add your own taxonomy ID or what?
I want to, so our animals are not present in GenBank ID systems quite often. And so we don't have a number we can put in place.
Jürgen already has answered for this.
I mean, you don't have to fill it. So if you don't need it, then you also can leave it empty.
That's the answer I was looking for. Thank you.
Well. And then here there's a text button, test. We have to select it and then check the test, how the results are looking. So this is the header that's found on the FASTA file, and the sequences and identifier rule. So our advice, you always check the test for the FASTA file that you uploaded. So the last thing is about adding the Crosslinker, but I already showed you yesterday how you could do it. Again, on this configuration panel, we will have one crosslink part. And then you need to add the name and the description. As I say, all this will be important later when you set your search settings. And where the specificity related to this Crosslinker. And then this is the end of our tutorial. But before we end, we need to make sure that you restart the MaxQuant to enable what you have done on this configuration, which will be also repeating. So we could also do it together. So we exit MaxQuant. And then we started. And on the we could quickly see on the configuration panel, The two modifications that we add are here. You can find them. So I think we should finish now.
Thank you, Şule, for
Thank you.
her talk.